we will discuss satellite subsystems. Before going to the satellite subsystems, the details of the satellite subsystems, first let us understand what are the different parts of subsystems. The basic system consists of a satellite, maybe one or more than one in space, relaying information between two or more users through ground terminals and the satellite. The space segment of the satellite system consists of the orbiting satellite, maybe more than one satellite, and the ground satellite control facilities necessary to keep the satellites operational. The ground segment, sometimes it is called the earth segment of the satellite system, consists of the transmit and receive earth stations and the associated equipment to interface with the user network. The space segment equipment carried aboard the satellite can be classified into two functional areas. One is called the bus and another is called the payload. Bus refers to the basic satellite structure itself and the subsystem that support the satellite. The bus subsystems are the physical structure, power subsystem, attitude and orbital control subsystem, thermal control subsystem, and command and telemetry subsystem. The other part is the payload, and the payload on a satellite is the equipment that provides the service or the services intended for the satellite. For example, if we have a satellite that is the uh, basic behavior of the satellite is to provide the communication facilities, that is a communication satellite. So the basic payload will be the communication subsystem. Okay, so payload actually depends on the nature of the service given by the satellite. So we will study some subsystems, and the subsystems are listed in this way, that is the attitude and orbit control subsystem, AOCS, telemetry tracking command and monitoring subsystem, TTC and M, power subsystem, communication subsystem, and the satellite antennas. Attitude and orbit control system, or AOCS. Why we require this particular subsystem? That means what is the function of that particular subsystem, and if that particular subsystem is not given or is not present in the satellite, what will happen, right? So let us try to understand why do we require this particular subsystem in the satellite. Generally, we send the satellite in the orbit expecting the satellite will stay in the orbit without any problem. For geostationary satellite, we want the satellite to stay in the sky at a fixed position. That is intended, right? But actually what happens, because of various issues, like because of the shape of the earth is not exactly spherical in shape, so it is little bit bulged out in the equatorial region, and obviously because of this bulging and also some other effects are there, we will discuss it in different section. The satellite will try to drift from one position to another position, right? So actually the potential around this earth should be equal, gravitational potential, but unfortunately gravitational potential is not same, and if the satellite is started drifting slightly, or it gets some other forces like force due to moon, force due to sun, something like that, they will start drifting and they will drift towards the stable condition, stable location at 75° east, and there is another stable location right here, that is 105° west. So satellite is subjected to different forces, right? Different forces are there, and because of those forces, the satellite will try to move from its original position to some other position. At the same time, the satellite may suffer from some kind of vibration, may be rotated around its own axis. That means the satellite antenna that should be pointed towards the Earth station may be rotated because of some other issues, right? So we have to make sure that satellite should be in its own position, should not oriented or should not change its orientation as per satellite's wish. Rather, we want to have a stable orientation of the satellite, and to ensure all those things we need this particular subsystem.